everybody. So I'm going to get the tests all graded this weekend, and I'll update your Canvas scores over the weekend, and I'll give you guys back the test on Monday. So our lesson for today is section 8.5, and I'm going to be doing it on the computer today because we're going to use some graphing calculator stuff. But 8.5 is almost the end of chapter 8. I think we have one more lesson, and then after that we have chapter 9, and then we're done. So we're getting really close to the end. And section 8.5 is all about graphing quadratic functions, or also just quadratic functions in general. Because a quadratic function is one where, like, we've been doing things. Let me find a slightly more difficult one. Oh, sorry, I'm used to doing it on the iPad. So we've been learning about how we can solve equations when you have something like this equals 0, right? So like you can do it by factoring, you can use the quadratic equation. But now what we're doing is we're looking at when do you, like, what does it look like when you have a function that equals some type of quadratic expression? So essentially there's going to be an infinite number of solutions, right? Because like this f of x you could replace with a y. And there's an infinite number of things that make that equation true. Because if you have y equals x squared plus 4, you could have x equals 0. And what would y have to equal in order to make the equation true? 4. And if y was negative, or sorry, if x was -1, what would y have to be? 5. If x was, say, 3, what does y have to be? Yep. 13, because you go 3 squared is 9 plus 4 would give you 13. And obviously these are not the only solutions to the equation y equals x squared plus 4, because you could also have x equal like -17/3 or something like that, and you could plug that number in. So the first part of your assignment is just finding some of the solutions, but keep in mind that there will always be an infinite number of solutions. And the way that we usually represent an infinite number of solutions is with a graph. So for example, with this function where we have x squared plus 4 equals y, if I were to graph that, it would look like this. So, and the graph of a quadratic function where you have like x squareds in it will always look something like this. It will have some type of curve, or we call the shape of parabola. And it might be like flipped upside down, or it might be wider or skinnier, but pretty much all quadratic functions will look something like this when you graph all of their infinite solutions. So any questions so far about the distinction between quadratic functions versus quadratic equations? Because when we had quadratic equations, rather than having it equal to y, we would have it equal to 0. And then you'd like try to figure out what x is. But when you have y equals x squared plus 4, or whatever your equation is, you're going to have an infinite number of equations, or an infinite number of solutions to it. So the first like 4 questions on your homework are basically just figuring out some of the solutions to a quadratic function. And then the next few questions after that are graphing functions. So they'll give you a quadratic function and you need to graph it. So to see how this works, let's look at some basic function transformations. So the most basic quadratic function is y equals x squared. That's just as basic as you can get. And there's 4 different things that you can do to a function like this that will change the way the function looks. So the first thing you can do is you can either add something to the x, like the part that's being squared, or you can add something to the entire function. So let's look and see what happens when you add something to the entire function. So let's say I add like a 3. When we look at this blue graph compared to the red graph, what do you guys notice is different about it? Like, how did the graph of the function change when we added 3 to the entire function? Okay, yeah, it moved up, right? And specifically, it moved up the amount that we added. So what would you predict a function would look like if I were to subtract, let's say, 5? What do you guys think it would look like?
Yeah, 5.
Perfect. Yep, let's see. Yep, that's what happens. Okay, so whatever number you add or subtract to the end of your function, that's going to shift it up or down. Then another possibility is rather than adding it to the end of it, we could add it to the stuff that's being squared. So if I put the x in parentheses and I add something inside of here, let's look and see what happens with that. So let's say I add a, I don't know, a 3 or something. What do you guys notice about that? So what's different about the blue one versus the red one?
Shifted it horizontally.
Yep, so it shifted it horizontally, and based on our last thing, we might think that it should move to the right, right? But in this case, it didn't, it actually moved to the left. And the reason for that is because -3 is the number that would make this term equal 0. So basically, the shifting left and right is going to be the opposite of whatever you add. So since we added 3, you're going to move it in the negative direction 3. So what do you guys think would happen if we minus 4? Yeah, it moved to the right 4. So you can move things up and down by adding or subtracting numbers, and then you can move the graph side to side if you add the opposite of whichever way you want to shift it. So since we added a -4, it moves it in the +4 direction. Okay, so adding and subtracting will shift things either up or down or left or right, depending on whether it's inside the square or if it's outside. The last type of thing we can do is we can multiply the x squared by something. So let's say we multiply by, I don't know, like a 5 or something. What do you guys notice about that blue graph compared to the red one? It's what? Yep, it's narrower. We can also describe this as that it's growing faster. So the reason for this is if I have x equals 1, which is right here, if it's just in my regular function, x squared, 1 squared is going to equal 1, which is this point right here. And maybe I'll do it with my mouse for those of people on Zoom. So this point right here is where x equals 1 into the original function. But if you plug in a 1 into the blue function, 1 squared will be 1, but then if you multiply it by 5, then it ends up giving you this as an output. And so that's why it gets skinnier if you multiply by a bigger number. Now, what if I was going to multiply by a fraction? Like let's say 1/4 or something. What do you guys think that would do? Yep, because in that case, when I plug in a 1, 1 squared is 1 times 1/4 will give you a 1/4 as your output, and so the parabola widens. Now, what if I were to multiply by the number 1? What would that do? Yep, it wouldn't change at all, right? Because 1 times x squared is the same thing as x squared. So 1 is kind of like the boundary point where it will be exactly the same. If you do a number that's bigger than 1, then it will be like a taller, skinnier parabola. And if it's a number less than 1, then it will be wider. Now, what about if it was negative though? What do you guys think would happen if we multiplied by a negative number? Yep, it would flip it upside down. So like if I multiply, let's say by a -2, then basically what that does is it makes the parabola skinnier, but it also flips it upside down. So essentially there's 4 different things that can happen in a parabola equation. You can shift it left or right by adding or subtracting something inside of the parentheses. So if I add 1 to this, it moves it to the left 1, because remember the stuff inside of the parentheses, it's actually not technically this number, it's what would x be to make that be 0 is technically what is causing that shift. And then, so that will move it left or right if you add something inside of parentheses. Then if you add something outside of parentheses, that will move it up or down. And that one is not opposite, it just shifts it up or down because you're essentially taking like this calculation and then you're adding 5 to it, which shifts it up. So you've got that, and then you've also got that you can multiply the outside by either a positive or a negative number. If the value of the number is bigger than 1, then that would give you like a taller, skinnier graph. If it's a fraction that's less than 1, it would be narrower, and a negative number flips it upside down. So that's like the most complicated that it gets. On your homework, you're going to have ones where they'll just do one shift. So for example, they might give you something like, I don't know, like y equals 3x squared plus 1, for example. And so what you want to do, because like you have to draw the graph. So what you do is you say, okay, well, first of all, let's figure out how much it's shifted. So the fact that there's nothing being added or subtracted inside of the square means that it's going to stay in the center, which we can see right here. But the plus 1 means it will be shifted up 1. And so that determines what we call the vertex of the graph, which is basically the point that's like at the bottom, or if it's upside down, at the top of the parabola. So the vertex is determined by how much you shift it side to side and how much you shift it up and down. Then once you figure out what your vertex is, then you need to determine how skinny or wide it is, as well as if it's right side up or upside down. And the way you do that is you just choose some number besides the vertex that's easy to plug in. So like I might say, okay, I'm going to have x equal 1. Well, if x equals 1, 1 squared is 1 times 3 is 3, plus 1 is 4. And that would give me this point right here. And I could graph that on my homework system. So you start off by looking at what's being added or subtracted to determine where the vertex has shifted to. And then you plug in another value to find the width of the parabola. So let's go through some examples on your homework because it's easier to see if you just do it on your homework. So on this, actually, let's do part C. So this is question 5. And on part C, we're asked to graph 3x squared plus 1 is equal to y. So in this equation, is there any shift from left to right? No, because in this equation, there's nothing being added or subtracted inside of the squared part. And so that means that the vertex or the x coordinate of my vertex is going to be at 0 because it's not shifting anything left to the right, left or right. But will it shift up or down at all? Yeah, it will move up 1 because of this plus 1 part of the equation. So I say, okay, so this is where my vertex will be. And you can see the graphing system makes it a parabola shape on its own. But you have to choose the second point that will determine how wide your parabola is. So to do this, you just say, okay, well, what's an easy number that I could plug into my equation to figure out exactly how wide it is? Because I know that it's going to be pretty skinny because it's multiplied by 3, but you need to know exactly how skinny it is. So you say, okay, well, probably plugging in x equals 1 would be easy. And if you plug in an x equals 1, what does y have to be? Yep, it'd be 4 because I'm graphing part C. So I do 1 squared is 1 times 3 is 3 plus 1 is 4. And so that's the point that I would use to graph this equation. Does that second part make sense to you guys of how you find that? Okay, and then basically you do the same thing. So like for this one, again, there's nothing being squared or there's nothing being added or subtracted inside of the square. So it's not going to shift left or right at all. The -1 tells me it's going to shift down 1. So my vertex is going to end up being here. And then I usually like to just plug in one number above where my vertex is. So I'll plug in x is 1 again. And if x is 1, 1 squared is 1 times 3 is 3. 3 minus 1 will give me 2. And so when x is 1, y should be 2. And that gives me this graph. So, and then you would graph part A as well. So you'll have some that are like that. And then there's one where you have like all 3 parts. So most of them will only do like one part at a time. So like this one is like making sure you understand what it means when you multiply by -4. that it's going to give you an upside down graph and that the vertex won't shift at all. So it would look something like my vertex is at 0. If I plug in a 1, I get a -4. So that would be my second coordinate. And this would be the graph of that function. And this red function that they gave you is just the basic function to kind of give you a guideline of what is shifting. So you'll have something like that. And then I think it's question 10, maybe. Yeah, question 10 is the one where you incorporate all 4 things. So in this case, what does this +3 tell us? Yep, so this +3 tells me I'm going to the left 3. And then what does the +2 tell me? Going up 2. So that tells me that my vertex is going to be at -3, +2. So that's my vertex. And then the fact that it's multiplied by a -3 tells me it's going to be an upside down one. And it's going to be a skinny one. But to figure out exactly how skinny it is, I would just choose some number that's easy to plug in. So I think x is -2 would be easy to plug in because I can say -2 + 3. That's going to give me +1. +1 squared will be 1. 1 times -3 is -3. Add 2 and you get -1. So when I plug in a -2 for x, I get this output -1. And you don't have to necessarily plug that number in. Like you could have plugged in a -1 and that would give you, well, actually, I guess in this case you would because you can't graph that point because it's lower than -7. But usually it's easiest if you choose the number right above it. The only exception to that is if you're multiplying by a fraction, in which case you want to choose a number to plug in that will end up canceling out your fraction. Do you guys feel like we need to do more examples of this, or would you guys like to get started on your homework? Give me a thumbs up if you're good to start on your homework. Thumbs down if you'd like more examples. Okay. Being mostly thumbs up. So if your thumb was down, I can just come around and help you out with your homework as you work on it. So raise your hand once you're ready for my help. Oh, sorry, there was one other type of question I forgot to show you guys how to do. And that's question 12. It's basically the same thing. They're just asking it a little differently. So on this one, rather than graphing it, they're asking you to identify what what it would look like. So in this case, what does the -3 tell us? Yep, shifting it to the right 3. So I'm going to draw this on the whiteboard maybe. So the -3 is going to tell me that I'm going to the right 3. And then what does the other -3 tell me? The one outside of the x squared. Yep, that one tells me I'm going down 3. So this is where my vertex is going to be. And so what that tells me is my vertex, I can type my coordinates in. The x coordinate is going to be, oh wait, yeah, I went +3. Yep. So the x coordinate should be +3 because this number tells me that I'm going to the right 3. Then my y coordinate should be -3 because I'm shifting it down 3. And then this -1 that's multiplied outside, what does that tell me? Yep, it'll be flipped upside down. So my picture is going to look something kind of like this. And so this second box, it says that this vertex is either the highest or the lowest point on the graph. And because my graph is an upside down graph, that means my vertex is the highest point. Then for my last step, I need to say what my range is. So your range is basically describing how far up and down on the y-axis your graph will go. So what's the smallest number on the y-axis that this graph goes to? And it's not actually a number. -infinity, right? Because this graph keeps on going forever. And so the lower part of my range is going to be -infinity. And then what's the highest number that my graph goes to? -2, right? And it can equal -2, so I'll put a square bracket around -2 and a round bracket around -infinity. Yeah. Oh, yes, sorry, it is -3, thanks. Yep, so that would be -3. And they didn't ask you for the domain, but what would the domain be? Remember, the domain has to do with the x-axis. What's the smallest number on the x-axis the graph could be? -infinity. What's the biggest one? Infinity. That's why they don't ask for it, because every single quadratic equation will always be from -infinity to +infinity on the x-axis. But on the y-axis, which is the range, you will have a boundary on it. So that's why they're asking for it. So that's how you do those ones. And I would recommend that you sketch out the graph when doing these, because it's way easier to solve these if you sketch it out first. So the range would end up looking like -infinity to 3, and you put square brackets around it. Oh, sorry, -3 I meant. So I'll let you guys go ahead and get started on your homework. If you have any questions, let me know. Mm-hmm.
I know how to do that as well.
Mm-hmm. They don't actually have very many of the ones with the hard versions. So how about I just make up some and we can work through those and then you'll be able to do these. Which is fine. So let's say we have y equals -1/3 times x plus 2 squared plus 5 or something like that. So what do you know from this information that would help us graph it?
The point that starts it is at 5.
Mm-hmm. 5 up, right?
Yeah.
Okay. And is it shifted side to side at all? Okay, so the side to side shift is determined by this part. And it's specifically going to be the thing that makes this equal 0, which in this case would be -2.
Okay.
So sometimes you, like a lot of people just look at this and make it the opposite because essentially that's what makes it 0.
Right.
And so in this case, you're going to go to the left 2, and then this tells you, like you said, that you go up 5. And so that gives you this point as your vertex. And then, so that we've used the information from here and here, but what does the -1/3 tell us?
But it's down 1/3.
Yeah, that would be true if it was a line without x squareds.
Fair enough.
I was trying to think if it might actually have an application here.
I'm just curious if I could have a correlation with y equals mx plus b.
It's analogous, it's not the same though.
Okay.
So like Because y equals mx plus b, the m thing that's being multiplied determines how steep the line is.
Yeah.
In this case, there's no line, so there's no steepness to it, but it does determine how squished or spread out it is.
Gotcha.
So the fact that it's negative means it will be flipped upside down. And the fact that it's 1/3 means that it will be fatter than if it was just like a regular x squared.
Okay.
And the way that you figure out exactly how much fatter it is you just choose some number to plug in for x that is not the vertex. So any number except for -2 will work. Because if you plug in -2, you're just going to get that point again, which isn't helpful. But I would recommend choosing a number to plug in that's going to make it easy to multiply by 1/3 so you don't have a fraction in it. So like I might do like 1, because if x equals 1, you'd get 1 plus 2 is 3, and then 3 squared is 9, and -1/3 times 9 will make it so you don't have a fraction.
Doesn't that affect the equation though? Like if you, because the x is supposed to be -2 to cancel it out to be 0, but if you change it again, it changes the equation.
Yeah, so if we have x's, so if we have x is -2, that makes this 0. 0 squared is 0 times -1/3 is still 0 plus 1.
Okay.
That gives us this point, but there's an infinite number of solutions to this equation. This point is just a special point because it's the vertex of the parabola.
Okay.
Kind of like how the y-intercept is like a special point, a special solution, because it's where it crosses the y-axis, kind of comparable to that. And so you say, okay, well, this is one of my solutions, but like I could choose any number. Like I could say, x is 0. 0 plus 2 is 2. 2 squared is 4. 4 times -4/3 is -4/3. And then -4/3 plus 5 is like 3. No. Yeah, 3 and like 1. Why can I not do that in my head?
It's a Friday.
Yes, that's the excuse. I think it's like 3 2/3 or something like that. But you don't want to try to graph that, right? Like that's really messy to try to graph. So the point is to try to choose an x that makes it so you don't have to add fractions together.
Okay.
Which is why in this case, I would recommend making x equal 1, because 1 plus 2 will give you 3. 3 squared will give you 9.
Okay.
And then 9 times -1/3 will give you -3, plus 5 will give you 2. And so that means that when x is 1, y is -2, and this point is a solution.
All right.
And when you graph this on your homework, it will kind of like automatically fill the shape in, and it will basically be a parabola that looks like that.
Gotcha.
That kind of makes sense.
Makes a lot more sense.
And you could do any number, like you don't have to do a 1, but you just want to choose to plug in something that's going to make it easy to calculate.
Yeah, it's usually complicated, but I think I got the basic gist of it.
Cool. Do you want to do another example, or do you want to?
Yes.
Yeah. Okay. All right. So let's do on this one, y equals 2. Actually, let's do another fraction one. Let's do 1/4 times x minus 5 squared minus 2. So where would you start on this one?
Push the -2 to show you where it's going to be on the y-axis.
Mm-hmm.
Just go down 2, and then so the x would have to be a +5,
Mm-hmm.
which would equal to 25. Yes, so that'd be 0.
Mm-hmm. Which
So,
will give you the vertex here.
yeah.
Mm-hmm.
And then guessing change go x to 1 so that way it's negative.
So we
Actually, no,
we kind of already, what was this one again? That if x is 5, y is -2, that's the vertex. And then you want to do x is 1. I think that would actually work though, right?
Yeah,
Because
because that would ended up being x, if the x is 1, that'd be -4, but then -4 to the second power is positive 16.
Mhm. And then positive 16 times 1/4 would give you,
4.
and then 4 minus 2 would give us a positive 2. Is that right? Because this stuff is 16 divided by 4 is 4. Yeah, 4 minus 2 gives you 2. So that tells us that this is a solution.
That's really weird, but like you can reuse different parts of the equation multiple times because usually with math equations you can't. Interesting. Yeah, I get it.
And so then you'd say like, okay, if x is 1, y equals 2. So that would be this point right here, which basically tells us our parabola is really wide and kind of looks like that.
Gotcha.
And on the later questions, when they ask for like the vertex and the range and all that kind of stuff, basically the vertex is just the coordinates of this. So you'd say x is 5, y is -2. That would be your vertex. Label that. And then the range would be everything or like the part of the y-axis that this graph is on. So in this case, we have a lower bound because there's no part of the graph that goes any lower than -2. So the lower part of our range would have a square bracket with a -2, but then the upper part of our range, it goes on forever.
Positive.
But then like on this last example, what would the range be here?
The range would be that'd be 5. Well, negative infinity and then 5.
Yeah. And then what would we do with like round and square brackets?
So round on the left,
Mhm.
square on the right.
Perfect. Yep.
Here's one.
Okay.